Find the derivative of g of x equals 5x minus 2 cubed times 3x squared plus 1 to the negative 2. Then evaluate g prime of 0. So g of x here is the product of two different functions. We have a 5x minus 2 cubed, and we have a 3x squared plus 1 to the negative 2. Which means we will make use of the product rule for the derivative. Another option, since one of the exponents is negative, it is possible to move that to the denominator and call it a positive exponent, in which case you'll have a quotient of two functions and use the quotient rule. Either way will work out. Since it's written as a product, I will just use the product rule here. The derivative, g prime of x, will be the derivative of the first function, 5x minus 2 quantity cubed. The cubed is the outermost. We'll use the power rule for it. So bring the power down, leave the inside alone, subtract 1 from the power, then multiply by the derivative of the inside to complete the chain rule. That's all the derivative of the first times the second left alone. Then add to it the first left alone times the derivative of the second. Now the derivative of the second will be, bring down the power, negative 2, leave the inside alone, subtract 1 from the power, and that'll be negative 3, and then the derivative of the inside, which will be a 6x. Our next step is to put constants together. We have that 3 and that 5. We can multiply them together to give us a 15, and then 5x minus 2 squared, and 3x squared plus 1 to the negative 2. And then we have this negative 2 and this 6x, and those can multiply to be a negative 12x. And we have 5x minus 2 cubed, and we have a 3x squared plus 1 to the negative 3 power. Now we're going to factor this result. We can start with the numbers. We have a 15 in the front of this one, and we have a 12 in front of that one. That has a common factor of a 3. So we can factor out a 3, which will leave behind a 5, and a 5x minus 2 squared, and a 3x squared plus 1 to the negative 2. Remember, we factor out a 3, so I'll leave a negative 4x. 5x minus 2 cubed, and then 3x squared plus 1 to the negative 3. I just rewrote everything else as is. Now we can factor out entire expressions because we have a 5x minus 2 squared here, cubed here. We can factor out the lower of the two powers, that's the 2. It factors out with the 3 that we just factored out. So we will have a 5x minus 2, lower powers 2. Now if we factor out 2 of those, that's going to take away all of them here, and 2 of the 3 there, and there's what the leftover result should be. So that means we will have a 5 and a 3x squared plus 1 to the negative 2, and we will have a negative 4x, and we have a 5x minus 2 to the first power, and we have a 3x squared plus 1 to the negative 3 power. The next thing we can do is factor out a 3x squared plus 1. We have that in each of them. We have here a negative 2 and here a negative 3. The lower power is negative 3. So we will have everything the same in front, except now we're going to factor out a 3x squared plus 1 to the lower power, which is the negative 3. Remember, negative 3 is lower than negative 2. It's more negative. Now, when we factor that out, factoring is subtracting exponents. Here's where it can be a little tricky. We're going to be factoring a negative exponent. Now, you subtract the exponents from the other powers, but we just factor out a negative exponent, so we're going to be subtracting a negative 3 from each of those, which is equivalent to adding 3. I mean, subtracting negative 3 equals adding 3. That's where it can be a little tricky with the negative exponent. But whenever you factor, remember that you actually subtract the exponent. It's the same reason why when we factored out the 5x squared from the entire expression, we had this one left over to the first power, because it used to be to the 3 power back here, and you subtract 2 from 3 and you get a 1. Well, now we're factoring out a negative 3, which means we subtract a negative 3, which is equivalent to adding a positive 3. So we're going to add a 3 to this first one. Well, 3 added to a negative 2 will be a positive 1, so we'll have one of those left over. And then here we'll be taking all of them out, because this will go to a 0, and anything to the 0 is a 1, and all of that will be removed then. And there's what we'll have left. So we will have a 5 times a 3x squared plus 1 to the first power. And then we have a minus 4x times a 5x minus 2. And we took out all of them from the second one. Okay, our next step now is to distribute this in here and this in here. And we'll have 3 times 5x minus 2 squared times 3x squared plus 1 to the negative 3. And then distributing that in, I will have a 15x squared plus 5. And distributing the negative 4x in, I will have a negative 20x squared and a positive 8x. So g prime of x equals 3 times 5x minus 2 squared times 3x squared plus 1 to the negative 3 times. Combining like terms together, I have a 5. It has no other constants. I have an 8x. And I'm writing the x squared term last because it's a negative here. 15 minus 20 is a negative 5. I figured it'd be best to put on the end. Generally, you write positive terms first, then negative terms. The only other step left to do is that we can move this here to the denominator and call it a positive exponent. So let's go ahead and do that. Everything else stays in the numerator. So we'll have 3 times 5x minus 2 squared times a 5 plus an 8x minus a 5x squared. And that entire thing divided by 3x squared plus 1 quantity cubed. There's our derivative g prime of x in its simplified form. The next thing to do is evaluate g prime of 0. So g prime of 0 means to plug a 0 in for each of the x's. We will have 3 times 5 times 0 minus 2, and then quantity squared. We have this 5 plus 8 times 0 minus 5 times 0 squared. And then we have the entire thing over 3 times 0 squared plus 1, and that whole thing cubed. Now back in the numerator, we have 3 times 5 times 0 is a 0, so minus 2 squared. And then we have 5 plus 0 and then minus 0, so just a 5. And down in the denominator we have 3 times 0 squared, which is just a 0. We're left with adding a 1, just a 1 cubed. So back in the numerator we have 3 times negative 2 squared, which is a positive 4, times a 5, and then all of that divided by 1 cubed, which is a 1. 3 times 4 is 12. Times 5. Anything over a 1 is itself, so we just have 12 times 5, which comes out to 60.